Cheetah brand electrical boxes, switches, and receptacles have been available for several years. They are designed to streamline electrical installations by eliminating the need for screws. This makes the installation process faster and potentially easier, particularly in certain situations. These boxes are typically constructed from a lightweight composite material. A key feature of the box design is a unique claw mechanism. This claw is intended to grip the drywall or plaster, providing a secure mounting point for the box. The switches and receptacles are designed to snap directly into these specialized boxes. A spring-loaded mechanism within the box holds the devices securely in place. The Cheetah system presents a novel approach to electrical installations. However, it has faced scrutiny from some electricians. Concerns have been raised regarding the overall security and robustness of the screwless connections compared to traditional screw-in methods. There are worries that the switches and receptacles could be more susceptible to accidental dislodgement. The cost factor is also a consideration. The Cheetah system may be more expensive than traditional wiring methods. The decision to adopt the Cheetah system is largely a matter of individual preference and project requirements. There are advantages and disadvantages to both the Cheetah system and traditional screw-in boxes. Electricians need to weigh these factors to determine which system best suits the specific needs and the demands of the installation. Some points to consider are firstly installation speed. The screwless design can potentially reduce installation time, especially for repetitive tasks. Secondly, ease of use. The snap-in design may be easier for some individuals, particularly in tight spaces or awkward positions. Thirdly, material. The composite material is lightweight and could be beneficial in reducing the overall weight of the electrical installation. Fourthly, security. Some electricians express concern that screwless connections are not as secure as traditional screw-in connections. Fifthly, durability. The long-term durability of the spring-loaded mechanism and claw design is a factor to consider. Sixthly, cost. The Cheetah system may be more expensive than traditional wiring methods. Seventhly, code compliance. Ensure that the Cheetah system meets all applicable electrical codes and standards in the specific jurisdiction. Eighthly, application. Consider the specific application and whether the screwless system is appropriate for the environment and the expected usage. Ninthly, compatibility. Ensure that the Cheetah system is compatible with other electrical components and wiring methods used in the installation. Tenthly, personal preference. Ultimately, the choice between the Cheetah system and traditional screw-in boxes comes down to individual preference and experience. Factors to consider when comparing the screwless system with traditional wiring methods are the reliability and long-term performance, the ease of modification and maintenance, the range of available components and accessories, and the availability of training and support. A proper understanding of electrical codes and standards is essential for all electrical work. In general, branch circuits must be designed to safely carry the intended load. National Electrical Code, or NEC, Article 210 covers branch circuits. The ampacity of conductors must be sufficient for the load they will carry. AEC Table 310.15b16 provides ampacity ratings for conductors based on their insulation type and temperature rating. Overcurrent protection devices, such as circuit breakers and fuses, must be sized to protect the conductors from overloads and short circuits. NEC Section 240.4 covers overcurrent protection. Grounding is essential for electrical safety. NEC Article 250 covers grounding and bonding requirements. All metal enclosures and equipment must be properly grounded to provide a path for fault current to return to the source. Ground fault circuit interrupters, or GFCIs, are required in certain locations to protect against electric shock. NEC Section 210.8 specifies where GFCIs are required. Electrical boxes must be properly sized and installed to provide a safe and secure enclosure for electrical connections. NEC Article 314 covers outlet, device, pull, and junction boxes, conduit bodies, fittings, and handhole enclosures. Wiring methods must be suitable for the environment and the application. NEC Chapter 3 covers wiring methods and materials. Conductors must be properly identified and labeled. NEC Section 310.11 covers marking of conductors. Electrical equipment must be listed and labeled by a recognized testing laboratory. NEC Section 110.3 covers examination, identification, installation, and use of equipment. Working space must be provided around electrical equipment for safe access and maintenance. NEC Section 110.26 covers spaces about electrical equipment. Safe work practices are essential for electrical safety. Always de-energize circuits before working on them. Use appropriate personal protective equipment, or PPE, such as gloves and safety glasses. Follow lockout/tagout procedures to prevent accidental energization of circuits. The 2017 NEC is the version referenced here. Always consult the latest edition of the NEC and local electrical codes for the most up-to-date requirements. The proper selection and installation of electrical boxes, switches, and receptacles are crucial for electrical safety and performance. Whether using traditional screw-in methods or newer screwless systems, adherence to electrical codes and best practices is paramount.